Alright, so our first practice problem is going to be 1 minus cosine squared x times tangent squared x equals cosine squared x. And I'm going to underline my problem. And you want to choose the more complicated side, and you want to try to boil it down to the least complicated. So I'm going to choose the left-hand side, 1 minus cosine squared x tangent squared x. And a tip off to know that you might want to use a Pythagorean identity is that you see a squared. Now that isn't always true, but that's one of the things that you want to look for, is if you see a square, maybe Pythag. So if you see a square, maybe Pythag. It's just one of those like things to put in your toolbox. And I'm going to even highlight that just to kind of see a little reminder that pops out on the page. So now we need to go down here and we need to analyze this. And I'm going to be honest, I haven't even worked out this problem, okay? So I'm looking at it with fresh eyes just like you. And what I see here is I could try to maybe change my tangent squared x into some sines and cosines. That's where I'm going to start. So let's go ahead and do that. We've got okay. I'm sorry. I just had like a moment. I just realized there's more ways that we can rewrite these identities. Boo. Okay, so just keep your eye out for them. But on this, I'm going to try to change my tangent into sines and cosines because I know that tangent is sine over cosine. Since these are multiplied together, maybe something will cancel there. So I'm going to rewrite it. 1 minus cosine squared x. But right here, I'm going to write sine squared x over cosine squared x. And there I'm using the quotient identity. And the way you can always check yourself to see if you're right or not is just look at what you wrote and does that equal tangent squared x? Yes, it does, because sine over cosine is tangent, and you have two of those, therefore tangent squared. Now I can do some canceling, or simplifying as I like to call it. So now we have 1 minus sine squared x. And my reason is simplify. And now I have something that kind of looks like a Pythagorean identity. I've got a 1 and I've got a sine squared. Okay. So let's think about this. If I look up at my original identities, this one right here, and I manipulate it a little bit, I'm going to do this work down here in that blank spot. I'm going to manipulate this identity so that I can get 1 minus sine squared x on one side of the equal sign. So I'm going to start with sine squared x plus cosine squared x equals 1. I'm going to subtract cosine squared x. Oh, I'm sorry. No, I'm going to subtract sine squared x from both sides. And I'm going to end up with cosine squared x equals 1 minus sine squared x. So I manipulated the identity. And these two things are equal, so I can substitute. And I'm going to highlight that. So those two things are equal, so that means I can substitute. And I've got cosine squared of x, which is what we were looking for. So that means I'm done. And over here, I'm just going to put Pythag. And that's it. So these are just going to be a little bit trickier to think about because you have to think about all the different ways that your identities can be manipulated. Alright, so another example. let's do sine of x minus cosecant of x equals negative cotangent x cosine x. So I'm going to underline the problem, and I'm going to try to pick the more complicated side. Now here's the thing. These have the same amount of trig functions in them, so you have to decide, do you want to try to create two pieces out of one thing, or do you want to bring two pieces together into one thing? I always like to take two pieces and bring them together. Okay, I don't like to create more pieces out of one piece. I want to make more pieces into one piece. So that's what I always do. And so I'm going to start with the left. I'm going to say, okay, sine x minus cosecant of x equals. And to bring two things together, when there's addition or subtraction in between them, we need to get common denominators. But something that I notice here is that cosecant can be changed into as 1 over sine. So that'll give me the denominator that maybe I try to get in common. So I'm going to start with sine of x minus 1 over sine of x. And that's using my reciprocal. And then, like I said, I'm going to get common denominators. So this sine of x is over 1, so I'm going to multiply by sine on top and bottom of that fraction. And I'm going to get sine squared x over sine x minus 1 over sine x. And there I'm just getting common denominators. I'm getting really close to the bottom of my page. Oh no. Okay, so now I'm going to combine those two fractions. I'm finally going to be able to turn into one chunk. And I've got sine squared x minus 1 all over sine of x. This is bad. I'm running out of room. Okay. Now I've got it into one piece. It still doesn't look much like that. Okay, but we're getting there. So now it's in one piece. And the clue here is that we need to see that we have sine squared x minus 1. That kind of looks like a Pythagorean identity. And if you look up to the ones that we manipulated earlier, you can see sine squared theta minus 1 is equal to negative cosine squared theta. So we can go down here. I'm going to do a big time no-no. And I'm going to go to the next page. This really isn't good for our notes, but I ran out of room. Okay, so equals, and if you look down there, we change the numerator to negative cosine squared x over sine of x. And the reasoning there was Pythag. And now we need to have a cotangent. So we've got the negative sign we need. We need to get a cotangent and a cosine. Well, we already have a cosine up top. So let's kind of break that off and set it to the side. So we've got negative cosine x over sine x. And here's our times cosine x over 1. So I kind of broke it off, set it to the side there. And here I'm just going to put break apart BA. And now, hopefully you guys can see, oh, cosine over sine. That's my cotangent. So I've got negative cotangent x, cosine x, using my quotient, and my proof is done. All right, so now, since we have this extra room on page 56, we might as well just do our practice problem right here in this open space. So our practice problem that I want you guys to do, and I really do want you to try, okay, even if you just make a total mess of things, I want you to try to manipulate this, and maybe you'll get the answer, okay? So here we go. secant of x minus tangent of x times sine of x equals cosine of x. And that's the practice problem I want you to do. Just one practice problem. So I want to see a valid attempt at working on it. Good luck.